Sketch a single continuous position time function with the following features, labeled and interpreted in the context of a moving object. So for this position time function, the domain is supposed to be greater or equal to 0 and then belong to the real numbers. So what we want to do here is we want to be able to see quadrant 1 and quadrant 4 on the XY plane. So I'm going to put an x-axis like so, and my y-axis like that. So on the x-axis we have t for time. On the y-axis we have the position time function, so it's going to be s of t. Okay. So that's going to be your domain there. The position time function is supposed to have 1, 0 on 2 positive roots. That means we have x-intercept at x equals to 0, and then 2 other positive roots, and we can put 1 over here and 1 over here. We want to have 1 maximum and 1 minimum point, so we can put a maximum over here and a minimum over here. And we want to have a positive displacement from the origin as well as a negative displacement from the origin. So the y-axis here represents the displacement of this object, this moving object, from the origin, which is right there at x equals 0 and s of t equals to 0. So in this graph here, whenever s of t is positive, we're talking about positive displacement from the origin. So positive displacement from the origin can be interpreted as, for example, traveling north, or an object being thrown up or moving forward. That will be a positive direction. Whenever the position time function is negative, so s of t is less than 0, that could be interpreted as traveling south or moving downwards or backwards. Okay? So at this point, so we have our positive displacement from the origin, we have our negative displacement from the origin. Let's graph this position time function. So it's going to look like a sinusoidal function, something like this. Okay. And now we are supposed to label the following points. Now, v of t, that is the velocity. The velocity is defined as the derivative of the position time function. So the velocity is essentially the slope of the position time function throughout its domain. So if we look at the first point that they want us to place, we want the velocity to be negative, so the slope of the position time function should be negative, and the position time function itself should be negative. So that point would be right here, for example. So that point right there would be a negative velocity, so v of t is less than 0, and s of t is also less than 0. Now, in the context of a moving object, what this means is that we're moving south, or moving downward, or backward, and we're moving away from the origin. So we can also say that here. We are moving south and away from origin. So that's going to be this one right here. The next point, we want the velocity to still be negative, But this time we want the position time function to be positive. So that will be right here. The velocity or the slope of the position time function at this point is negative, and the position time function itself is positive. So we would say that the velocity at time t is negative, less than 0, and the position time function is positive. So this would be an example of an object moving south or downwards or backwards towards the origin. So we're moving south and towards the origin. The next point, we have a velocity that is positive, and we have a position time function that's negative. Okay, so that will be right here. So our velocity is positive. The slope at this tangent slope at this point is positive. So velocity is positive, and the position time function is negative. So velocity is positive, and position time function is negative. And this, interpreted in the context of a moving object, means that we're moving north. We're moving up, right? North or up or forward. And we're moving towards the origin. So that was this point right here. The next point, we have a positive velocity and a positive position time function. So an example of that would be right here. It could also be right here, okay? So at that point, we have a positive velocity. It's a positive slope, tangent slope at that point. And we have a positive position time function. And in the context of a moving object, this means we're moving north and away from the origin. So that was this one right here. And the next point, we have a velocity of 0 and a position time function that is positive. So that's going to be one of the turning points, specifically the maximum here. So at this point here, we have the tangent at that maximum. The slope of that tangent is 0. So the velocity equals to 0, and the position time function is greater than 0. And what this means is that we are not moving. But our position is to the north of the origin. So we are stationary, north of origin. And then finally, the last point here is that we want to have a 0 velocity and a negative position time function. So that's going to be our minimum here. So at that point, our velocity, wrong color. At that point, our velocity is 0, and our position time function is negative, which means that we are not moving. And in this situation here, we are stationary south of the origin. South of the origin.